Hello guys, good morning, good afternoon, good evening from wherever you're watching from. My name is Mo Friday. In this short tutorial video, we are going to be taking a radical expression. In my previous video, if you have watched it and if you have not watched it, please kindly go back to where I talk about exponents. And I mentioned that at the end of this part of exponent and the properties of exponent, I'm going to go into radical expression. So before we go into solving radical expression, so it is better we understand, or we have a better understanding of what radical expression is, and how it can help us solve the question that we have as we proceed in this class. Okay, so without further ado, so let's go straight to this. Okay, I don't know if you can see clearly. Please hold on. Okay, yes, so let's continue. But um, first off, look at what we have here. We have radical expression. So let us have a better understanding of what it is. Now let's define the nth root of n raised to power. This n root of a, right, is equal to what? N raised to power 1 over what? N, where n is a positive integer, right? So if n is a positive, if a is a positive integer, so we have nth root a is also called the principal nth root of a. That is this expression that you have here, right? It's called the principal nth root of a. So we now have in this expression that you see here, in this expression, n is called the index of the radical, right? So n, this value here, is called the index of the radical, and the symbol, this very symbol here, this very one here, is called the radical or radical sign, and the expression a under the radical, which is this, is also called the radicand. Okay, and it's very important we understand this. Might not seem so important, but they are very necessary that you understand what those terms are, so that eventually it is being used elsewhere, you can easily follow through and have a better understanding. So now this is true. Please know that for a b real numbers and n a positive integer, for this expression it is true for whenever b is in absolute form, n is what? N must be even, and b, when b is not in absolute form, n is also what? Odd. So these are just basic theoretical part of radical that you should understand. So I'm going to go straight to writing the properties of radical. So just as we have the exponential properties, or you can call it law of indices. So but just as we have the exponential properties, so we are going to go ahead to writing the properties of radical expression. So in this video, I'm going to keep it short, just giving you the properties of radical expression. So in the next video, after this very one, we'll go to solving, taking examples to that illustrate this property. So let's quickly go and write in these properties of radical expression, right? So let's quickly look at the property. So the property one we'll be considering here is quite simple. We'll be looking at this very property that says, let me put this in this form, in nth a dot nth root of b. So nth root of a multiplied by n root of b will definitely give you n root of what? A, b. Very simple. Very simple. So we'll take examples in my next video, but just follow through as I express the properties of radical expression. Okay, so the second expression we're looking at here, the second properties we're looking at here will be nth root of a over b, okay, further expressed as nth root of a over nth root of what b, okay, provided b is not equal to 0, because if b equals to 0, that becomes an undefined expression which cannot be further used. Okay, the third one we're looking at here, just right here, the third one we're looking at can we remember this? Okay, the third one I'm looking at that will simply be when we have, let's say we have m roots of what a, okay, and then we have yeah, we have n root of what b, right? So this finally becomes m and yeah ab. I believe this is true. What it is. And the first one, I'm going to confirm this anyway, so let's just proceed. So the first one, let's say we have n root of a, right? Now this is index to what? This index to m, right? So this will be further expressed as n root of n a raised to the power what n. So let's confirm what I wrote down. Let's be sure that is true. Of course, that seems to be okay. Okay, know what it is. So what it is, this should be this n root of 8 now have square root of what nth root of na, right? This now becomes mn root of what a, provided a is equal, provided a is greater than equals to 0. So there are examples in forms of question that will appear in this form, so you're expected to be able to deal with and probably memorize them and understand where to apply what properties to solving the mathematical problem as they present themselves. So let me just go through it again so for understanding, and if you read through the previous one saying this will come in numbers in figure form anyway. So n root of a multiplied by n root of b, this is called n root of a times b, right? So this is n root of a all over b. This becomes n root of a all over n root of b, provided b is not equals to 0. This n root of n root inside carrying another root, this is n root of a. This becomes become mn root in a, provided a is greater than equal to what? To 0. This last one says that n root of m index n will give you n root of a or bracket index of what? M. So we are going to take an example that illustrates all of this in my next video. Please do stay tuned. Just stay tuned as I will walk you through examples on how we can fully express this. Thank you so much for staying tuned to the end. My name is Mo Friday. If you are yet to subscribe to my YouTube channel, please do subscribe to my YouTube channel so you get updates and get notified whenever I upload subsequent classes. After Radical, we will go to different topic, probably factorization to understand, and other topics too. But I'm going to list them out. I'm going to take topics in this so that probably that is in sync with whatever we are doing right now. So stay tuned in my next video, and bye bye for now.